Okay, good. So I'm saying today's concept will be Snowflake performance optimization. Okay, so you may be working as a developer or DBA. Okay, so whatever it is, generally when we go for interview, there will be a question on performance optimization. Okay, so how do you improve, performance of the Snowflake system? So actually, this is the last concept within our any within my training, because this concept requires knowledge of all other services or all other topics, because we will be touch base based on all other topics. Okay, so Snowflake performance optimization. So now I will tell you what is performance optimization. Performance optimization means improving the performance of system. Okay, so you have a Snowflake. Okay, you are running jobs on the system, and actually jobs means in our data warehouse or data analytics industry, we means loading data from source to target. Okay, source can be anything, target will be Snowflake system. That's what we do. Okay, if you work on Snowflake, Redshift, BigQuery, whatever it may be, our job is only loading data, extracting data from different sources. Okay, transforming means applying different transformation rules and then loading into target. This is what we do. So so in this job role, improving system performance is what actually is performance optimization. So because some customers are very big, means they have huge volumes of data, even hundreds of terabytes, thousands of terabytes. So while loading that, system will be stuck actually. Okay, it cannot process. Okay, so but still they need to meet the SLA, so their job should be completed. That is the reason they will have a production support team to monitor the jobs. Okay, there is a dedicated team even to monitor and make sure jobs will complete on time. In case of any failures, they will restart it. So that is the production support team. In fact, they will give outsource this job to other companies like TCS, Infosys, Wipro, all service-based companies. Generally, the product-based companies will outsource this work to these people, so that their job is to monitor their jobs, make sure jobs will be complete on time and no issues. Because production support is that important. So in case of failures, they have to make sure they should restart the job, and they complete within the SLA. If there is any issue, that's why in production support, the people, they focus on operational efficiency. Operational efficiency means, for example, all the jobs are now running 12 hours. They will focus on how to reduce the 12 hours to 8 hours. Or they're running for 8 hours, let's say. Then how to reduce that 8 hours to 6 hours or 4 hours. So that your system resources will be free. 8 hours means what? The system is used for 8 hours. Means system resources are used for 8 hours. Means the virtual warehouses are there, right? Virtual warehouses. So they are running for 8 hours. So the virtual warehouses, okay. So they will be running for 8 hours. That means they will be charged for 8 hours, right? Yeah, they will be charged for 8 hours. So the moment you reduce, the moment you reduce the time, so the virtual warehouses also, their time, consumption time also reduce. That is the way it will be cost saving to the customer. Okay, performance optimization actually cost saving. For example, you see when I click on create data warehouse, for example, you see. Okay, so you select anything. See here, this cost is depends on 6 credits per hour, 12 credits per hour, 24 credits per hour. Okay, so for example, if you are using 10 hours means 10 into 6, that many credits. If you are using 24 hours means 24 into 6. So that many credits you have to pay. So for example, 10 hours your jobs are running, 10 into 6, 60 credits. Okay, and each credit is generally some $2. Okay, generally $2, $3, $4 based on the edition. So let's say $2. Then 60 into 2, $120. Okay, per day we are charging, or we are paying for the Snowflake. But you reduced the job from 10 hours to 5 hours. Then 5 into 6, 30, 30 into 2, $60 only you're paying. That means you reduced 50% of the cost of the company. So performance is directly proportional to the cost that customer is paying. So it is very, very important that a developer or support engineer or even the solution architect, they will have sound knowledge on the performance optimization. Okay, so that's why in interview this is a definite question on the performance optimization. Okay, so okay, there are again two things within the performance optimization: system performance and query performance. Okay, so both will reduce the cost of the query and both will improve the system performance. So I will tell you, actually, for the company, performance means overall system performance. Okay, system performance should be improved. But how can system performance will be improved if there are bad queries running on the system? System performance will be poor if the queries running on the system are running longer. Okay, for example, I'll tell you one example. Let's say there are running 100 queries, okay, every day. In fact, every day we will run thousands of queries in the production. Okay, so I'm telling, at a time, okay, at the same time means simultaneously or concurrently, 100 queries started. Okay, so if the system is running well and queries are optimized, 100 queries will just come into the warehouse and they just complete within fraction of few seconds, and all 100 queries will be completed just maybe in 5-10 minutes for, and your system will be free. But out of 100 queries, let's say one query stuck means it's running longer, it only taking all the system resources. Okay, all the system resources means entire, for example, you have, okay, some, okay, four, okay, for yeah, x large, okay, you have 4x large virtual warehouse, so it is only using all the 4 virtual warehouses. That means it is eating up all the resources. If it is eating all the resources, then that query is not completed. At the same time, other queries also cannot be completed, although they hardly run 2-3 seconds. But because this particular query is taking all the system resources, so it will not allow other queries to complete because they are not getting resources, because all resources are occupied with this long running query. So entire system will be stuck with those 100 queries for a long time. Long time means till this long query completed they cannot complete because they are not getting the resources. This long running query occupied all the resources. So your system will be like stuck condition, means you will see 100 queries running for 3 hours, 4 hours, or even 8 hours, 9 hours. So at that time you will see the system is stuck, and sometimes it will lead to shutdown of the warehouse. So you have to restart. But even after restarting, unless you fix the issue with that query which is running or which made the system to stuck, the issue will again occur, right? Even you restart 100 times without fixing the issue, what is the use? No use. So the long running queries will lead to the system slowness or system stuck. So basically my point is, the queries or issue within the query will lead to issue within the system. That's what it is. So basically, so if your queries are really doing good, means they're just completing very fast within fraction of seconds, fraction of seconds, not even second. Okay, within milliseconds. Even you run 100 queries or even 1000 queries, they'll just come into the system and just flash within the fraction of seconds they will complete. Okay, so system performance will be good if your queries performance is good. So that's why in the interview, or do you have any idea about any query optimization? They generally refer to the query optimization. Okay, that's why I'm telling. Okay, we need to know. Okay, within the query optimization, now we will discuss what are the things. Okay, we need to see. Okay, if all the queries are running, automatically system performance will be good. Okay, and once we discuss the query optimization, I will tell you. Okay, so I will tell you one of the scenario how the interviewer will bring you to the point of system performance. What he will tell is, for example, you will tell about he will tell I have one query. Okay, how do you improve the performance of this query? Okay, so then you'll say that so I will take that query and see. Okay, so what are all the tables involved and see are there any joins? Okay, and how they are joined. Okay, fine. So for example, you see. So let's start from DPT, right? So his query can be simple query. I mean, this is very simple query, but it can be a complex query also. Okay, so I'm just giving the simple query. Sometimes he will say I have very simple query. Okay, so let's start from table, but this query is running longer. What do you do? That is what his question. Okay, so see now today till now I have not used this explain, but now you see before running this query. Okay, as a first step, I will run this explain plan on that query. Okay, so explain plan, what it will tell is it will give step-by-step procedure how it will going to process that query. See here, if you run select star from table, it will run that query, okay, and give the result. But if you give explain, it don't run that query. See, I'm running the explain means I just put explain before the query. Okay, see it just says a step, then id, parent operators, operations, objects, alias, expression, okay, partitions total, partitions assigned, bytes assigned. Okay, so whatever the query may be, let's say a query which is running longer, okay, you will take that and as a first step run the explain plan. In the explain plan, you will see okay how many steps it will take to complete, and each stepwise metrics also you will see. Okay, so whether it's a table scan, okay, or result set or what, so you need to see okay each step and what it's doing, okay, based on this. Okay, and how many partitions it is scanning. Okay, sometimes if you see for example your query has some 10 tables and some of the tables don't have partition applied. Okay, partitions applied, so then we recommend to create partition. Anyway, I'll come to that point. First, let us understand what is these columns: partitions total, partitions assigned, and bytes assigned. Bytes assigned are basically the bytes processed at that step. Okay, so basically the steps where the more bytes are assigned, that step is actually a long running step. Okay, so we need to see okay where the more data is being scanned. Okay, this table scan is there, right? So we need to see where the more data is scanned, and we need to pay attention there, especially the objects involved in that step. Okay, so and see whether are there any okay so micro partitions. Okay, we need to see whether any clustering applied on the table or not. Okay, So clustering we discussed, right? Clustering will sort the data. Okay, so micro power. So that's why during the interview itself, he will ask what is micro partitions, what is clustering. All these topics he will ask actually. Okay, during the interview itself. But during the performance optimization, you have to touch base actually. Or even if you don't ask any of those questions, the moment he asks about performance optimization, we have to touch all those important concepts while answering this question. So in the explain plan, we will see how many steps it will take, and the data scanned at each step, and a number of partitions involved in each step, and bytes assigned at each step. So generally, the more the bytes assigned means that much data is scanned. So those are the tables we can focus and see whether any clustering is applied on that. If there is no clustering applied, then it is advised, or in fact, it is must to create clustering on those tables, because clustering will actually sort the data. Okay, um so of all the within the micro partitions. Okay, so and also you need to pay an attention. For example, you see, I'll apply this where location equals to Hyderabad. So now you see, I had a filter on this query. Now I'll run the explain plan. See here, the first one, now four steps are there. Okay, table scan, last one. Okay, so 1536. Then the next one is filter. So you have to pay attention to the filters. On what columns filters are there. Okay, so generally the filtering column you will apply the clustering. Okay, so for example, HYD. Okay, where location equals to HYD. So wherever there is filters, you need to make sure they are created within the clustering. Okay, clustering is applied on those filtering columns. If you read about the clustering concept, we mentioned what columns we define the clustering. Clustering is basically we can define on the filter conditions or where clause conditions, because if the table may be 1 TB, but for example here we are querying only location equals to Hyderabad, but Hyderabad records may be very less. So at that time you don't have to scan the whole table. That's why these columns are called predicates. Predicates means generally the joining columns, the columns used in the joins, the columns used in where clauses or filter conditions. So those columns. So on that we can apply the clustering. So it will filter all the unnecessary data and it will filter only the required data. So we need to apply clustering on those columns. So let's say, okay, so I'll create one join here. Okay, this is direct select, right? So select star from d dot start from dptd join dpt and join with dpt underscore view. Okay, this is view on d dot dpt number equals to v dot dpt number. Okay, so okay, so let's say this is my query. If there is any matching records, you'll get the data, otherwise you don't get the data. Okay, I have matching records, so I get the data. So okay, so if it is a join, how the explain plan will look like, I just want to show you. Okay, see here, table scan, first depart. Okay, this one is scanned actually, DEPT, partition zone, partitions assigned, and byte scan, and then joining column d dot depit number equals to department dot depit number, because the other view also department view, inside also the table department is only there. So it joined, and then another table is also scanned. Okay, so there is also so and so, then filter is applied, then join. Okay, join applied, and finally, okay, total, okay, 3000. So like that, we need to see what are all the tables that are used and they are joined, and what are all the filters are there. Okay, so and wherever the filters are there, it is recommended to create clustering on those filters, on those filtering columns. And we should, I mean, basically the bytes assigned will give you the hint. Okay, here we are seeing very less, like 1536 and all, but in the real time the tables are very very big. Okay, each one is 1 terabyte, 2 terabytes, even sometimes 10 terabytes. So at that time we have to make very very focused on joining columns, filtering columns, and applying proper filters. Okay, these things we need to pay attention. Okay, so and I will tell you here. First one, what is the first one in query performance? I will check explain plan. I'll check explain plan for the query that's running longer. Okay, so from the explain plan itself, okay, we'll be able to see, okay, how many steps the query is taking and what are the different. In fact, you will be able to see all the tables in this itself. Otherwise, normally from query only you can see, but from the query you cannot see how big the table is. Okay, while seeing the name, how can you say? But in the explain plan, you can easily say against this column. Okay, by its assigned. So based on that, you will automatically know, okay, which is the larger table. Otherwise, you can also see from dbc dot tables for each call, each table, how big it is. But that's a different, while explain itself you can see. So no need to go and check in the dbc dot tables where table name equals to so and so. Okay, in the explain plan itself you can see. So based on that, you can see, okay, what are all the big tables, and put focus on the big table. Small tables will complete anyway. Okay, they are not the major issue, but focus on the big tables, because big table joining or distribution, anything will be a problem. For example, you see you have 100 kg bag and 1 kg bag. Which one is easy to carry or move from one place to another? 1 kg bag only, right? So actually there is no issue with the 1 kg bag. Issue comes with moving or trying to carry a 100 kg bag. So the system performance will be impacted only with the major tables or big tables. Okay, so we have to put focus on larger table and apply proper filters on the larger tables. Create, okay, clustering keys on the larger table. Okay, and apply proper filter means apply the filters to which only, for example, this department is only 100 million records, let's say, but you want only department location equals to Hyderabad. Okay, you want only Hyderabad data, then better that you apply the filter on Hyderabad only. Otherwise, it will fetch every data. Okay, so which will occupy the system resources. So if we apply the specific filters, it will not move the entire table. It will first only filter the required data, and it will give it to you. So applying filters, basically it will filters the unnecessary data, okay, which need to be processed. So that means all these steps we will know only by checking the explain plan. From the explain plan, what you will see, we will see what are all the big tables based on the bytes assigned, and we will also see what are the joining columns. See here, join columns. Because your query is 2 pages long, you can't even know, like how the query framed. because I'm telling in production queries, sometimes they are even 2 page, 3 page, 5 pages queries will be there. You don't even know how to, I mean, what are the tables involved and what are the columns joined and all. But in the explain plan, you can clearly see from down you can come, and in fact by its assigned you can see, okay, which table it is, how much data is scanned. Then you can take the table and see, okay, so then apply proper clustering on those filter columns and see if, for example, here d dot location. So then you can make sure that location is clustering defined. So like that you will get all the ideas from here. So let's say here I'll do change for this. For example, I'll remove this join. Just I put comma. Okay. So let's see what happens. Actually, inner join, okay, can be written. This is another way of writing inner join. One is I put first time join, right? Join on and then filter where location equals Hyderabad. So some people will write like this, okay, not join. They just put comma and table this one, okay. So they will. This is also inner join. That's why you will see the, okay, you will see the same plan, okay. So for example, there is no where clause, okay, only comma department view. Now see here. This is called Cartesian product, okay. So these are very dangerous. Cartesian product means product join. Okay, so if there are missing join conditions, you will see Cartesian join or product join within your explain plan. Okay, so I will tell you what is that. Okay, so see here how many data you came, 36 rows you got. So this is what product join means. Both the tables will get multiplied. If for example table A is 5 rows, table B is 4 rows, then you will get 5 into 4, 20. But actually, you can do one practice: create two tables, employee department, okay, and check what is the count for inner join. In fact, we first to count discuss these classes. Check what is the count for inner join, what is the count for left outer join, what is the count for right outer join, okay, what is the count for full outer join. Not only count, records you check. Create two tables like employee and department table, and take what is the output for inner join, left outer, right outer, full outer. Generally this question they will ask in the interview. Okay, so if you write syntax properly, you will do inner join, left outer, right outer, full outer. But if you miss any of the join condition, it will go to product join. Product join means the records will be multiplied actually like this. For example, if table A has 10 records, table B has 20 records, then output of the product join will be 10 into 20, means 200. So like that. So we should avoid product joins by all means. How do you know product join is happening or not? You will see Cartesian join within the explain plan. So the moment you see Cartesian join means, okay, there is some missing join condition. You have to see, okay, what is that missing join condition? Okay, so and you have to replace that missing join condition with proper join condition. Then the query which is running for maybe hours will be completed just within few minutes. Product joins are so dangerous. In fact, because of the long queries, sometimes they will miss as well. And these things you can find during testing itself. But since in the development environment, test environments, there is no proper data, so the query may be completed in the dev and test environment. But in the production, since the table's original data will be there it will give issue. At the time you will not be able to find where is the issue. So just by applying the explain plan, you can see the Cartesian join. Okay, that means you can see that okay, I have okay, they have missed the join condition here. You can place those join condition within that query. Okay, so then that particular query will be completed. So yeah, that one. So then he will say that okay, entry will say that okay, so okay, I have my tables all correctly, their join conditions are correctly there is no product joins, and there is no Cartesian product joins, and all the clustering is applied properly, but still my query is running longer. Whatever you say, okay, that is taken care. Okay, you say that I will apply filters on where clause columns, okay, applied, but still my query is running longer. Okay, I'll create clustering on the where clause columns I created, but still my query is running longer. Then I will see is there any Cartesian joins. Okay, I'll replace the missing join conditions with proper join conditions. Okay, you did. Okay, but still the query is running longer. What will you do? That means basically interviewer wanted you, and he wanted to check your depth of knowledge and your width of knowledge. Okay, so whatever you say, okay, that is taken care, but the still query is running longer. What do you do? Okay, so then okay, that means you have checked with respect to. Okay, then the one more thing is you need to bring that point of data skew. Data skew. Data skew means, yeah, I have already told this point during the initial classes. One of joining columns will have either null value or duplicate value. Okay, means joining column is repeated at some duplicate values. For example, a table has 100 million records. In that joining column, one column only has some 50 million values, null values. Remaining 50 million only unique value. So if you join with that column, it will get skewed. Okay, skewed means unique values you join will complete faster, but joining with this okay null value or duplicate value will take more time, because all null values okay will be processed by okay one CPU, or within the virtual warehouse there will be cores, right, processors. So that only will process that slowly. Okay, because all the values went to one particular node. If it is unique values, they will be distributed equally okay among all the nodes, so it will be faster. But if there are any duplicates on the joining column or null values coming more on the joining column, that will lead to skew, and that will take more time. So we have to see if there is any skew on the joining column. Then the interviewer say that okay, there is no skew. Okay, so still my query is running longer. What is the issue? Then you have to tell that okay, there may be heavy load on this system, okay, which is impacting the this query performance. Then he will say that no, I have checked, okay, there is no load on this system, only this particular query is running, nothing else is running. Okay, so that means whatever you tell, that means he is asking you to tell possible reasons, all the possible reasons. Okay, then you say that yeah, there is no load on the system, there is no data skew, okay, there is no product joins. Okay, so and you have applied all the clustering for on all the columns. Okay, all the joins are taken care. Okay, so but still the query is running longer. Okay, so okay, so okay, then okay, you can say that okay, so maybe there, yeah, you already said maybe there is a heavy load on the system. Then he said that no, there is no load on this system. Okay, only regular queries are running. Then you can say that if there is no issue with the query, then there is a possibility that your system capacity is very less. Less means, for example, system capacity means the wait, I'll tell you. For example, right now my system is this is my warehouse, right, prod warehouse. So what is its capacity? It has only one, okay, one node, that is x small, means that is the least, okay, smallest size, okay. So and I have one virtual warehouse, one node only. So but I'm running a major query, okay, which this particular capacity is not sufficient. Then you may think that I will increase the system capacity, okay, you can tell that option, okay. Then the, okay, I may, because x small is very, means virtual warehouse size I will increase, that is what your next response. Of course you can tell, because interviewer wanted to know whether you know what extent you know. Then he will say that there is no load on the system, okay, what is the use of increasing the virtual warehouses? If there is a high load on the system, of course, okay, it makes sense, okay, you can add okay, cluster size. So okay, there is no load on the system, so only this particular query is running, so no need, I mean, do you think it is any significance of adding one more node? Okay, okay. Then okay, so there is no issue with the query, and and he says that the cluster capacity is also sufficient, okay. In fact, he also says that every day it is running fine with the same one node of x small, okay, but it's running longer today. Then the last point, you can say that, okay, if there is no, okay, if there is no issue with the virtual where, I mean, capacity of the virtual warehouse, here I'm talking, means I want to increase from 1 to 2, means I want to add a few more virtual warehouses, but yeah, interviewer says that that, do you think that is the issue, because there is nothing is running on the system, so adding virtual warehouse actually does not required, because nothing is running, so it's only not proper solution. Or he said that you don't have rights to add, because you are a developer, right? So you don't have rights to add, so what do you do? Okay, then, okay, so if there is no issue with the query, okay, if there is no, and everything is taken care properly, there is no load on the system, and system also provisioned with correct number of virtual warehouses, but still, okay, a simple query is running longer or taking time, means there may be an issue with the nodes itself. Nodes means virtual warehouse, right? Virtual warehouse will have this kind of x small, small, medium, these things will be there, right? For example, see, virtual warehouses, yeah, these node types, x small, small, medium, large. Actually, when you say x small, inside there will be process, okay, where inside means within the data center. Okay, so only what is cloud? Earlier you have the process in your data center. Now it is there in the cloud provider data center. But there is some CPUs running, okay, behind the scene. So those virtual warehouses are not performing properly. This is the last, okay. So because the system is every day running with x small only, and every day running this query fine. But today nothing is changed. Everything is fine. Okay, so but the same query, and in fact there is no load on the system also, but the same query is taking time. That means the processors or the virtual warehouse itself is not performing well. Okay, so at that time what you should do, okay, the same x small size virtual warehouse you are using every day, but today this is not performing well. That means you see, there can be a problem with the processors also, right? They may be in data center, but they also sometimes will be down, or they sometimes they will also perform degraded performance. At that time we can inform to the Snowflake support team, okay, and we need to give our warehouse, okay. So this is our warehouse, okay, ID, or you see account is there, right? Account admin, this one. So we can give, or as soon as we tell our customer name, they will know, okay. So okay, so as soon as we reach to the customer support team, okay, hey, my warehouse is not performing well, it's degraded, okay, all the queries, even simple query is not running well, it's running for hours and hours. then they will see the backend investigation. They will check the nodes. Okay, they will check, okay, how many nodes we are using, what node type we are using, whether x small or medium large, and how many number of nodes. But here in this case we are only using xmol, and that xmol is running, or it's degraded, or it's down, or it's not performing up to speed. Then of course they will have their softwares, okay, to investigate these CPUs. Then they will say that, hey, there is an issue with your virtual processors or virtual warehouse. Okay, we are rebuilding, or we are replacing. Okay, there are two things they will do. If it is a minor issue, they will rebuild the virtual warehouse. If it is already degraded and not ready to use again, then they will replace that. Okay, so yeah, we are replacing that virtual warehouse. Or let's say you don't have that much time, they will ask you, okay, forget about it, you can create one more virtual warehouse. Okay, that means when you create, what happen, you can create one more like this. Okay, and you can, okay, run your queries on this virtual warehouse. So that you can do from your end itself. Okay, you don't have to wait. For example, this is, okay, prod 2, and you can create this and create warehouse. Okay, that's it. I don't have to wait for this one. Okay, so I can just drop it, or actually it is suspended, so it is not you know charged, so you can leave it also. So you can use this warehouse and you can run your queries in this. So basically, what is the issue? What is the issue here? The virtual warehouse was degraded and not performing very well. Virtual warehouse means the process, the nodes within that virtual warehouse. Okay, the cores, the CPU cores will be used, right, in the data center. They are degraded. Okay, and that you will not know from your end. You have to reach out to the Snowflake support team only. They only can do that investigation and tell whether it's functioning properly or not functioning, or it has an issue. Okay, so that is the last step we will be doing. Okay, so in fact, if you are working employee, yeah, this kind of situation you will see. Okay, this will occur once, I mean, sometimes it will occur. Okay, so sometimes the, because after all, hardware means either it is our hardware or their hardware, it will fail, or these issues are expected. But we'll first do all these investigations, and once we found that there is no issue from our end, then we will reach out to them, just to check if there is any issue from the course of the virtual warehouse. Then they will check it and they will confirm, yes, there is an issue, we are replacing. But instead of waiting for them, they will immediately advise you, okay, you can create one more virtual warehouse and proceed. Of course, if any some experienced people are there in the team, because they have this experience, so immediately they only will, for example, they don't have time, okay, to wait, they only immediately create like this, okay, another virtual warehouse, and they will proceed with their loads, because the job is important to meet the SLA. Then instead of reaching to the Snowflake support team and waiting till they come back and investigation, they will do this work around immediately. Okay, because they're experienced people, so they just immediately provision one more cluster and run their query and complete that query within the SLA, and then they will investigate. Okay, check with Snowflake support team separately, hey, what happened this, okay, this warehouse. Then they will say that, yeah, this is issue with the underlying, okay, node of the virtual warehouse, and we have rebuilt it. Okay, that's fine, then it resumed its services. But they immediately provisioned another cluster and completed. So that's what an experienced person makes the difference in the team. You don't have to wait till the issue resolved by their support team. He knows what is the workaround, how to do it, and he does it, and he completes the job within the SLA time. So what is important here? Completing the jobs within the SLA is important. Okay, so yeah, so since the job is completed, Then he will reach out to the Snowflake support team on what happened with this existing warehouse, why it was not running or why it is slow. Then they will find out, and of course management will ask also why, what happened this, why it did not perform. Then we will give, whatever the response given by the support team. And that means the course or the process of the existing virtual warehouse were degraded. Okay, so or they have to be replaced, and they replaced it. Okay, now yeah, it is back to normal, like that. So yeah, these are the different things. Okay, we will um yeah, we will check in case of performance issues. So all these things you can just tell within just 2 to 3 minutes. Yeah, that's it in the interview. Okay, so that means this question, what happening is, it will show us what is our depth. Okay, what is our depth of our understanding about the subject and about the issues. Okay, and how to troubleshoot and how to act. Okay, and how to improve also the query performance. So that's why knowledge of SQL is very very important. Okay, so how to rewrite queries, how to apply filters, how to joins, okay, product joins. If you know all these things, you can improve the query performance. So if the query performance is improved, automatically system performance is improved. Okay, if the queries are running, if they're not running longer, that means system will automatically performing good. Okay, so query performance will lead to system performance. So like in this example I have said, we have checked all the things, but still query is not performing well, and it is running hours. And so that means at that time there is a issue with the system. Okay, which we confirmed through the help of Snowflake support team, because they only can check from the backend and see whether the configured virtual warehouses are functioning properly or not. Okay, so once they check, they will know. Okay, they will see everything in their system. So if they're not performing up to speed, means they will say, okay, we need to replace them. Once they replace, then system will be back to normal. So that's what query performance means. There is no issue with the query. Okay, and if there is issue with the query, means queries are running longer, means it is the query issue. If all queries are just completing within fraction of minutes and fraction of seconds, not even minutes, fraction of seconds and in a few seconds, means there is no issue with the query. And at that time we have to see, after checking all these things, okay, joins, filters, okay, clustering columns and product joins and all, after checking all these things, we have to check with the virtual warehouses also. Okay, and that too, since we cannot check it, we have to reach out to the support team and they will confirm. Okay, if there is a urgency, like you need to complete the job, then you can provision one more virtual warehouse, okay, for time being, and you can complete your job. And then, okay, after your job is completed, you can even reach out to the support team or Snowflake support team to check what happened on the other virtual warehouse, why it's not performing. Okay, and you can know the root cause. So yeah, that's the thing. Did you understand anything or any doubts?
No, Krishna, as of now.
Okay, yeah, go through this video. Okay, and yeah, all these points are important, because in every interview they will ask, have you done any time performance optimization? If you done, like, what have you done, can you please check, like that, they will tell. So yeah, we better answer whatever we discussed. Okay, so actually, yeah, this is the last session actually, within our actually training. Okay, so take a few days time, like today is Wednesday, right? So Wednesday, Thursday, we'll meet again on Friday, means day after tomorrow. Okay, if you have any questions, we will discuss. Only one day time for you. Okay, take time today and tomorrow, and we'll meet on Friday. If you have any questions, we'll discuss that. Okay, overall, any questions, anything from beginning to end, or any clarification required, we'll discuss that on day after tomorrow, Friday session. It is purely so question answer session. Okay, or any clarifications required, I will answer. Okay, that is the actually formal closure. After that, anyway, on the same day I will tell you, okay, what are the next steps, okay, how to. But anyway, before next steps of proceeding job, I will, you have to, answer few of my questions. So for that we will plan one day. If you are good in answering questions, then we will apply for the jobs and all. But our next session will be on Friday, purely question answer session. Okay.
Okay, Krishna.